Dear all, welcome to Civil Services with ZAKI. Today we are going to discuss about Tonga eruption impact on the Earth atmosphere. So as you know, it is related to our basically UPSC PT 2020 third PT series. And as you know, this PT series is very significant because this type of the content and material you can't find anywhere in the other places. So basically, whether it is YouTube and other places. So because this uniqueness on our basically presentation and such type of the best graphics, best animation and all that, you can easily understand the phenomenon regarding the science, geography, ecology, environment and all that. So that's why please subscribe our channel and tell your friends and colleagues. And as you know, now you can directly contact with me via our own app, Civil Services with ZAKI, this app. So this app is very significant. Basically, it is the milestone for your preparation for the civil services examination because it contains mains topics, prelims topics, and also test series. So you download this app, and also you can find 3 test series, present free test series, and also you can join regular test series in our this app. And also you can also join our live class sessions for the clarifications of the any questions, and any question, if you have any question regarding the science and tech, geography, ecology, environment, then you write in the comment box and also tell your friends and colleagues, because this is your forum. This is your forum. So this is basically a students forum. So you can also find study material on my app. So that's why download this app and tell your friends and colleagues. So let's we move forward and see the today's topic and what are the major subtopic in this topic, basically Tonga eruption impact of the Earth atmosphere. And as you know, it is related to the geography, and basically as you know, you find about what is the atmosphere and all that. So see what are today's topics. First, the most destructive part of the volcano eruption. So this volcano is one of the largest eruption in the recent history or recorded history. So that's why what is the destructive part of this volcano, and basically concern regarding in the scientist and all environmentalists. So first we discuss about the most destructive part of the volcanoes eruptions. Second, we see the data collected by the NASA's Aura satellite. So basically some of the data after the eruptions in January 15, 2022. NASA satellite collected data from the various layers of our atmosphere. So that's why this study is also one of the most significant topic. Another is volcanic eruptions and cooling effect of the atmosphere. So as you know, major volcanic eruptions causing cooling effect of on the global level, like the Krakatoa volcanic eruptions in the Indonesia in the 19th century. So the cooling effect, basically these type of the cooling effect in previous century, it means 19th century and after the 20th century. So one is most significant event, you know about the year without summer. So that's why large volcano create a cooling effect. So but this volcano, means Tonga volcano, is a unique. So what type of uniqueness is in this volcano, we can find in this topic. And also the decrease in the amount of the ozone and methane. So after the eruption of this volcano, also the ozone layer can be damaged because the decrease in the ozone gas. And also good news is that methane layer is also decreases, because as you know, methane is the most powerful greenhouse gas. Another is world record created by Tonga eruption. So several world records. So most these 4 world record basically fastest atmospheric wave ever recorded. Number 1. Number 2, Meteotsunami. So what is Meteotsunami? Meteotsunami across the globe. And another is powerful wind above the Karman line. So what is the Karman line and what is the above such type of the powerful wind, and also tallest plume in the recorded history. So also it is the tallest plume recorded history. So that's why these topics are very significant, because in this volcano created several world record. Another is as you know, question for the UPSC. So why this topic is relevant for the your civil services prelims 2023? So that's why we provide you a question, basically question for the UPSC. And another is answer of the previous question. So answer of the previous question, so asked by me in the previous video, this video. So answer of these videos also we provide you in this video. So we move forward and see step by step. Number 1, context. So the Tonga Hapai volcano erupted in January 2022. So it's become the most powerful explosion on Earth. So you imagine, because the most powerful, because it is equivalent to the force of 100 Hiroshima bombs. So when the atom bomb was dropped on Hiroshima in the first human history, it is the largest explosion made by human at that time. So imagine, this volcanic eruption is 100 times greater than the Hiroshima bombardment. So the explosion sent shock waves around the planet and causing the atmosphere to ring like a bell. So as we know the atmospheric circulation, so atmosphere ring like a bell. So generating tsunami battered nearby coast. So basically it is very most destructive waves and all that. But because it's happened in the middle of the Pacific Ocean and the less population at that area in this area, so that's why only 4 people killed in this explosion. So less human damage, but it is the most powerful explosion recorded in the human history. So let's we see the why this is the most destructive part. For the human history, this volcano. So see here. So first we also see the volcanic eruption. As you know, we provide you the best graphics, best animation to understand each and every parts of this. So as you know, the satellite recorded this eruption. So see here the record. So see, this is the basically Tonga volcano eruptions before and after the imaginary. So this image collected by the various scientific agency like the NASA, like the Maxar satellite agency, and all some of the oceanographic research in US. So this is the basically combined picture with the several satellites and some of the ground report taken by the scientist and collected by the scientist. So see here, see this is eruptions. So this is eruptions of the volcano. So see here, it is 15th January. So it is 15th January 2022 triggered massive ash in cloud. So see here. So if you see here, this is basically after the explosion in 18th January. Before, you can see here. So see the satellite pictures of the debris scattered in the oceans. So see here these area. So it is the volcanic pictures in April 2022, and it is 6th January 2022 picture. So see how they create, and finally 18th January 2022 22 pictures. So see before and after. So this is 29th December 2021 and it is 18th January picture covered by the S, and so it is the port village, and also the human house. So human house near the Tonga. So see here, and after the explosion see the this type of the S and all that. So it is very significant for the our climate and all that. So if you see here, if you see again, see again, see here, see here. This is basically, if you see here, see, this is here, see. So eruption is, see how big the eruption. So see here, see here, see. It creates shock wave across the globe. So that's why, and that's all. See here, as you know, it is various. So see. So basically these pictures taken by the Maxar satellite footage, and Maxar satellite footage revealed that the debris and the remnant of the volcanic island is spread across the sea. See here, across the ocean. Basically it is situated in the Pacific Ocean. So see here, see here, see here. So this is the picture of the island in April 2021, 10th April. After, if you see the 1 year, it's all filled by the sediment, basically by the volcanoes you see here, and finally they blown up. So only this time these remnant and some small remnant still present. So this is the 29th December port. So port near Tonga, and so see after 18th January. So this is the one of the most powerful explosion in the human history, and recorded human history. So let's move forward, see what is the most destructive part of the volcano eruptions. So basically when the underwater volcano in Tonga erupted in January, it's breached out more than as volcanic and also spewed about 58,000 Olympic size pools worth water vapor in the atmosphere. So it's also spewed about 58,000 Olympic pools. So as you imagine Olympic pools, so it's about 58,000 Olympic pool swimming water go to the space, and space means not the troposphere, it's go to the above stratosphere and the mesosphere. That's why the major concern in the scientists. So as you know, this water vapor could end up in the most destructive part of the volcano eruption. So basically these water is, as you know, these water vapor create the global warming effect. So that's why a scientist is very concerned about these water. So basically it's also increase global warming and also deplete ozone layer. So it's also these water also very dangerous for our ozone layer, because it can decrease the ozone. So see here, data collected by the NASA Aura satellite. So how you can imagine or how you can quantify the 58,000 swimming pool, because these data collected by the NASA satellites. So see here, the newest study and researcher used data collected by the NASA Aura satellite assess the amount of water that thrust into the stratosphere. As you know, stratosphere. So what is stratosphere? Stratosphere above the troposphere. If you go from the surface of the Earth to the 12 to the 18 kilometer, it's called troposphere, and basically tropopause present about 10 to 12 kilometer, and after 10 kilometer to the 50 kilometer present stratosphere. So it's go to the stratosphere, and beyond the stratosphere it's mesosphere. So it's revealed that 1,60,900 tons of additional water vapor in the stratosphere. So that is very significant. As you know, less water present or less water vapor present in the stratosphere, and less weather activities present in the stratosphere. If you want to know more about what is a stratosphere, what is troposphere, what is Karman line, etc., then you must watch our this video. As you know, we provide you the various video regarding the geography, science, tech, and all that. So you can watch this video and see what are the layers of the Earth atmosphere. So let's see here. And entered the stratosphere since volcano erupted, reaching the maximum altitude about 53 kilometer, which is the mesosphere. So it basically cross the stratosphere and go to the mesosphere. That's why scientists concerned about these water vapor. So this makes the largest and highest injection of the water in the stratosphere. So it is the record, the largest and highest water injection in the stratosphere done by these Tonga volcano. So since the satellite began the taking measurement, so basically the scientists taking the measurement is very difficult to quantify these water vapor, because as you know, if you go to the troposphere, you can go to higher and then feeling the cooler. So after, but you can go the stratosphere. After stratosphere, you can go up above, and you can warming effect increasing. So that's why if a volcanic eruptions happen, the volcanic ash and volcanic vapor go to the upper level, and it's easy to quantify in the stratosphere, because stratosphere upper layer is cool, and the magma and some of the gas is the hot. So you can easily quantify, but when these gas entered into the stratosphere, so it's difficult to scientists to quantify, because the stratosphere already very hot, because ozone layer and some of the radiating heat already present. So that's why it is very difficult. So that's why NASA use our satellite and all that devices to quantify these water. So after this, it is very significant discovery. So the excess water vapor equivalent around 10% of the amount water typically present in the stratosphere. So it is the 10% of the amount of the water typically present in the stratosphere. So water vapor may remain in the stratosphere around half a decade. So it means these water vapor don't go anywhere till the half of the decade. So these water vapor may be present half a decade in these stratosphere. So let's we move forward and see volcanic eruption, cooling of the atmosphere. As you know, most of the large volcanic eruptions create cooling effect across the globe. So normally big volcanic eruptions release, why? Because it's releasing a large amount of the ash and gas, basically type of sulfur dioxide. So sulfur dioxide creates reflective compound in the atmosphere. These volcanic byproduct, basically these volcanic byproduct, basically reflective compound, block the sunlight from the reaching the planet surface, so which cool the atmosphere. So sunlight would reach the Earth's surface, basically it's create cooling effect. So however, the Tonga eruptions produce surprisingly low level of sulfur. So it's also one of the surprise for the scientists and one of the concern for the scientists, because these eruptions produce less sulfur dioxide. So with the similarly size the explosion. So and the most of the ash ejected quickly fell to the ground. So most of the ash ejected quickly fell in the ground, as we saw the debris and all that in the in our animation, previous animation. That's why it is very destructive for the our atmosphere, and also major concern for the scientists regarding the scientists and environmentalists who basically studies and research on the climate change and all that. So let's move forward and see the as a result expert initially. So first because these as basically quickly fell ground fell in the ground is quickly, so that's why first at the first site researchers say it's basically minimum effect of the climate because it's not create a cooling effect. But here researcher and expert makes a great mistake, because the injection of these water about the 58,000 swimming pool water, Olympic swimming pool water. So because these excess water, the excess water researcher want could have the, so no after revealing by the satellite, the researcher found that these water radiating effect, so cooling effect converted into the radiating effect by this volcano, so could be warm the atmosphere much as greenhouse do. So this means Tonga explosion will be likely the first eruption in the record to cause warming effect. So remember this, Tonga eruptions is one of the unique because they create warming effect for the atmosphere rather than the cooling effect on our planet. So that's why it is major concern, as we know we also facing challenges regarding the climate change and the global warming. So we move forward and see another concern of the scientists, and another concern is decrease in the amount of ozone, but also good news for decrease in the methane also. So the researcher also pointed out that sharp increase in water vapor could decrease the amount of the ozone in the stratosphere. As we know, the layer of the ozone presented in the stratosphere, so thus the potentially weakening the ozone layer. So this Tonga eruption can be weaken or weaken the weakening basically produce the weakening effect of this ozone layer. So as you know, ozone layer protect life of the earth, basically ultraviolet rays. And what is ozone layer and what is the treaty on the ozone and all that, if you want to know more about that, know more about that, the ozone and all that, then you must watch our this video, a specific video on ozone. So as you know, we provide you about hundreds of video regarding the science, state, the geography, ecology, environment, whether it is ozone, whether it is El Nino and La Nino and all that. So that's why this channel is worth for you. You can find every study material, video and all that, and if you want to these videos, study material and all that, then you must download our app. So let's note only negative but also some positive news by these this explosion. Positive news is that this is also decrease the methane, main greenhouse gas. So however, the researcher also think increased water vapor could decrease amount of the methane. So why it decrease ozone? As you know, ozone is O3, and these OH ion in the H2O means water break down these ozone, and finally they produce O2. So that's why it's the ozone layer. So similarly, these this OH ion also decrease the methane. So increased could vapor decrease amount of the methane in the atmosphere, which one of the main greenhouse gases responsible for the climate change. As you know, methane is the most powerful greenhouse gas than the carbon dioxide. So For all methane and all that, then you can join our regular class on the ecology, environment, science taken, all that. You can also join free classes by the UP government Abhyuday scheme in the IIMT and also Gautam Buddha University, where currently our class is running. So you can also join, and if you want to know also, you can join directly on our app, this app. So also please download this app. So the same OH ion that react with the ozone also react with the methane and produce water and methyl radicals. So that is positive news and that is negative news, but overall these water create warming effect on our planet. So see next, world record created by Tonga eruption. It's also notable that please write down your book and booklet. World record created by Tonga. Basically, these main four world record. Number one, if you see, the fastest atmospheric wave ever seen. They sent, basically this eruption, it sent massive pressure wave ripping throughout the atmosphere around the globe. These waves are the fastest ever observed within the atmosphere. So it is the fastest wave ever observed in our atmosphere, and it's reaching speed about 1158 kilometers per hour. Imagine. Some of the 200 and 202.5 or 300 or 350 kilometer per hour typhoon or cyclone can devastate earth, and as you know how damage, but it is the 1158 kilometer per hour waves. So see how greatness about this Tonga eruption. Another record is fast traveling Meteotsunamis. Tonga eruptions sent ripple racing across the ocean produce teeny fast traveling Meteotsunami. It means, what is Meteotsunami? Meteotsunami created by meteorological phenomenon. So meaning a series of waves driven by air pressure disturbance. So basically it is driven by the air pressure differences, and here Meteotsunami, remember Meteotsunami, it is meteorological tsunami. It's not meteoroid or asteroid related, it is meteorological. So if you see another, as we also warn you and all our students, please don't buy the notes in the street and all that. Because why? Because if you see this type of the local booklet, you find Meteotsunami means meteoroid tsunami. So meteoroid tsunami created by meteoroid called Meteotsunami. It's not. It's meteorological tsunami, and also it is created by the pressure difference between the atmosphere. So it is weather related phenomenon, not the ground related phenomenon. So that's why. So it's appear in the Pacific Ocean, Atlantic Ocean, and the Mediterranean Ocean. So that's why this record is also the fastest traveling Meteotsunami ever recorded in the history. Third record is the powerful wind above the Karman line. High above the Earth's surface, beyond the Karman line that marks the edge of the space, it means 100 kilometers. As we know, if you see our previous video, basically in the structure of our atmosphere, this video, you can find the Karman line. A Karman line, basically the Karman line, from the Karman line to the ground, it's called homosphere, and some of the basic weather phenomena and all that, basically Karman line, beyond the Karman line, basically it's a space. So basically Karman line is the boundary between the space and our atmosphere. So it means you can't find the wind above the Karman line, but due to this explosion, a fast wind, powerful wind, shock waves trigger the eruptions, trigger powerful wind with speed 720 kilometer per hour wind above the Karman line, above the 100 meter. So such type of the shock waves is 1158 kilometer per hour, and it is the wind speed is 720 kilometer per hour. As you know, this is reported by the space.com reported. So this video is very significant for you, because we basically done very research and read various articles to collect these such type of the record. So another is the tallest plume recorded in the history. So volcano plume was the tallest ever recorded. So picking up to the 57 kilometer. So if we see the plume above there, so water go into the 53 kilometers, but the volcanic plume and gas reached to the 57 kilometer above the earth. It means it was basically go to the mesosphere. And previous record holder, so as you know, also you find about the previous record holder, like the who was the first and who was the second, like who set on the moon first, Neil Armstrong. Second, Edwin Aldrin. So that's why you can also know the Neil Armstrong and also know the Edwin Aldrin. That's why you can also know the this Tonga eruption. Also you can know about the Mount Pinatubo. Mount Pinatubo is the second highest eruption go to the tallest plume in the history in 1991, and it is basically situated in the Philippines, and it's extended to 40 kilometer. 40 kilometer, it means it's limited to the our stratosphere, but this eruptions is go to the mesosphere. That's why it is a very one of the tallest plume in the recorded history. So that's all about these volcanic eruptions. These volcanic eruptions is the most powerful volcanic eruptions in the recorded human history. So we move forward and see what is the relevance of the this topic in the UPSC. So see question for the UPSC. Consider the following statements. The big volcanic eruption released large amount of the ash and gases, thus cooling the atmosphere. Number 2, Tonga eruption produced surprisingly high level of sulfur dioxide compared with the similarly sized explosion. Third one is the Meteotsunamis are created by a strong seismic wave due to large volcanic eruption. Fourth, the Tonga eruption decreases the amount of the methane and ozone in the atmosphere. Which of the above statement are correct? 1 and 3, 1 and 4, 2 and 4, all of them. Please write the answer in the comment box and don't forget to subscribe our channel. We provide detailed answer of this question in this video, upcoming video. So please, this video and all, please subscribe our channel, tell your friends, and please share this video in your groups with the colleagues and all that. So let's we move forward and see answer of the previous question. Answer of the previous question. Consider the following statement. NASA space launch system is the most powerful rocket ever built. Yes, it's right. NASA space launch system is the most powerful rocket in the history, in the human history till present date. So it's one is right. So one is right. Second, dirt spacecraft specifically made for the study of the asteroids. It's wrong. It's not made for the study for the asteroid. It's made for the deflecting the orbit of the satellite, because dirt is double asteroid redirecting test. So redirecting the orbit. So it is the planetary defense system of our system project of the NASA. So it is very significant project, as you know, and also we discussed in our previous video. Third is InSight mission is specifically made for the study of the interior of the Mars. It's right. As you know, InSight recorded the largest volcano on the largest quake on the Mars. So Mars quake. So it is about the 5 in magnitude. So it's also right. 3 is right, 1 is right, 2 is wrong. Fourth, the Event Horizon Telescope is situated in Australia. It's also wrong, because Event Horizon Telescope is the network of the global radio telescope. It's not a single telescope, Event Horizon, because this specific telescope made for the capture the image of the black hole and all that. Presently, about 11 telescopes across the globe situated, one in Antarctica, one in Europe and Africa, and in the South America and all that. So you can see our previous video about the detail of this Event Horizon Telescope, because this telescope captured the first galaxy picture in 2019, and also in 2022 it's captured the picture of our own Milky Way galaxy black hole. That's why this project is very, very significant. So this is wrong. So 1 and 3 is right. Which of the above statement are correct? 1 and 2, 1 and 3, 2 and 4, all of them. 1 and 2 wrong, because 1 is right but 2 is 1 and 3 is right, 1 and 3 is right. 2 and 4 wrong, all of them. So your answer is B. Your answer is. So that's all about the Tonga eruption. Hope you understand about the various phenomena regarding the Tonga eruptions and why the Tonga eruption is unique. Because all such type of the big eruptions and basically create the cooling effect, but it's create cooling rather than the warming effect. So that's all about our today's topic, and please don't forget to subscribe our channel and press the bell icon, and also please download this app, and also you can find the test series, and also you can join our free live classes on the all subjects regarding the complete Indian geography, and also you can join our this type of the physical geography, world physical geography. So these are the one of the significant topics regarding the civil services examination, whether it is PT or mains. So thanks for watching this video. Thanks a lot. We will meet in the next week with the next video.